Hello, welcome to my instructional video on calculating TSS and BOD loading. Total plant flow is measured. This is used for reporting and for our plant records. Total plant flow is used to calculate loading rates to the treatment plant and to the environment. Influent and effluent samples are taken over a 24-hour period. The sample volumes are proportionate to the plant flow. So as the plant flow increases, so does the sample volume, and when the plant flow decreases, the sample volume also decreases. Influent and effluent samples are brought into the lab where qualified lab techs do various tests on a number of samples, including TSS and BOD. These results are entered into a database, and then software programs compile the lab data as well as our plant flow data and generate process reports with TSS and BOD results on them. The process reports are used by operations staff to make process changes and to help optimize the treatment process. This is what a typical process report looks like. This is a process report from our plant, and we've highlighted November 20th on this particular process report, and we're going to use the data from November 20th to do our calculations. So to calculate the TSS and the influent, we take the flow into the plant measured in million liters per day, which happens to be 66 million liters, and we multiply that by the influent milligrams per liter of total suspended solids. It happened to be 196 milligrams per liter that day, and the effluent TSS was 5 milligrams per liter. So we multiply the flow, 66 million liters, by 196 milligrams per liter of TSS in the influent, and the result is 12,936 kilograms of total suspended solids that came into the plant that day. Then we calculate the kilograms of TSS that went out in the effluent, that goes out into the environment. And we multiply the flow, 66 million liters, by 5 milligrams per liter of TSS, and we come up with 330 kilograms, or 0.33 metric tons. Then if we want to calculate the percent removal, we subtract the effluent TSS kilograms from the influent TSS kilograms, and we divide the difference by the influent TSS and multiply that by 100. And in this case, we came up with 97% removal. Now we move on to BOD. BOD is biochemical oxygen demand, and it's a measure of the amount of dissolved oxygen needed by aerobic biological organisms in a body of water to break down organic material present in a given water sample at a certain temperature over a specific time period. So November 20th, the influent BOD was 276 milligrams per liter, and the effluent BOD was 5 milligrams per liter. And of course the flow was 66 million liters that day. So we multiply 66 million liters by 276 milligrams per liter of BOD, and we get 18,216 kilograms, or 18.2 metric ton. To measure the effluent BOD, we multiply 66 million liters by 5 milligrams per liter of BOD, and we get 330 kilograms for that day, or 0.33 metric ton. Then to measure the percentage of removal, we subtract the effluent kilograms by the influent kilograms. we get 17,866, and we divide that number by the influent kilograms, and we multiply that by 100, and we get 94.7% removal for that day. Here's a picture of an influent sample and an effluent sample. The influent sample is what comes into the treatment plant, and the effluent is what leaves the treatment plant and goes into the environment. And as you can see, there is a clear difference. And that concludes my presentation. Thank you.